set of hybrid models today built in any logic, and we're going to be starting with some very, very simple models and working up to something more complex. And fundamentally, we're going to be looking at the combination of three major types of systems modeling. System dynamics, particularly sort of aggregate stocks and flows, and then agent-based modeling, and then discrete event simulation. Okay, and we'll look at different models that pair these, and then we'll look at one model to rule them all that includes all three. And we may have a guest lecturer at some point that will provide an additional example, but with a fresh, young voice. So the first model I wanted to look at was a very, very simple model that joins together two types of modeling, namely the DES and an agent-based modeling. And to do this, I'm going to open up this simplest, so give me a second here, simplest ABM process hybrid. Okay, yes, okay. So here we have a model where we have a person whose state is given by being one of two states, either seeking care or not seeking care. And then we have a sort of trivial, excuse me, let me get this projector working. Then we have a trivial sort of DES model here where we have a service represented where a person enters this processing, they proceed for delivery of a service, and then they leave that processing. Now, this is representing sort of the flow of a process at a high level. We can imagine, of course, elaborating what currently is shown as a service here with any number of different operators in the DES framework, having multiple paths, having people switching, having looping, having hierarchical descriptions. But the idea here is to exhibit this in its simplest form. There's a population then of people, and each of these people has two states that they can be in, either not seeking care or seeking care. When they proceed between these states according to a rate, the rate is given by simple transition in this case, and importantly, they no longer seek care when they're delivered a message that indicates that they're cured of their malady. So I'm going to run this model, and then we'll go in and take a little bit more look at how this is how this occurs. You'll notice that over time here, people are coming into this model for service. We have this population of 100 agents, and of course we can drill down to particular agents, some of whom are seeking care and some of whom are not. And when they seek care, they go and they present up here. They go through the service where there's some waiting time, and then following that they leave. They're actually delivered care in a way that cures the malady here. There are also cases where individuals balk, so they actually leave the system. because of overly long waiting times. And we can represent them through timeouts, for example, if we were to make a connector here for them to go to the exit. Currently, they pass in this sort of linear fashion. Okay, so this port up here would allow us to characterize balking if the service time is too long. So let's go see how this occurs. Fundamentally, we have agents. The agents present for care and are treated in a DES style model here. Okay, so we could represent, as you know, from discrete event simulation, a highly articulated care process involving resources, resource-limited delivery of care, such as the need for doctors, for treatment rooms, for diagnostic equipment, operating theaters for procedures, etc. In this case, we've abstracted all that, but retained the key idea that you present for care and then you wait while you're in care. And then that the care influences the patient. Okay? So patients outlive the care here. Traditionally, in DES, people come in, they're treated, so they come in, they sort of materialize out of thin air, they're treated, and then they vaporize at the end. Here, we have a whole population that's being maintained between visits to the facility, and their health state is affected by their treatment at the facility. So let's go take a look at a concrete level how this is occurring. Of course, I boiled this down to the very most simplest case. So people begin in this not seeking care state. They proceed to the seeking care state according to a rate. So they remain in not seeking care for an average time of 1 over 0.01. In other words, for 100 time steps before seeking care. Now, this is the key nexus. This and one other point are the key nexuses where the two come together. This is at the heart of capturing how people go from being simply agents embedded in a population to actually presenting for care in a system which is resource limited. So in this case, what we have is we have a situation where when they enter the seeking care state, there's this action that occurs, and basically what it's asking is for the main class, the place that they enter that DES system, to take this person in. Okay? This takes the person under care, accepts them under care. And what is this magic enter? Main, those of you will recognize, this is AnyLogic 7. So main here is a reference to get main. We've been doing it in classes. You get underbar main, remember that? Now you can simply say main dot, okay? And in this enter, what's that? Well, let's go up and see right now. So let's go to main here, and there it is. It stands before us. Here's enter. So we're telling this entry point here, which is of type enter that we could grab from the palette. It's an entry into this sort of system. We're telling take us in there. And then from thenceforth, they simply proceed down here as normal. So this service, for example, it's a service taking agents. It has a delay time. It has some maximum queue priority associated with it. And there is this possibility for people to enter with different priorities. And then there's, you can also set it so that there's a timeout. In other words, people can balk, and so we could set it so that they leave when they've been there too long. Think about an emergency room, and at some point, you say this, I'm not sure if this is really a problem, and I may get sicker from staying here with the various types of people, and I'm being triaged. I don't know when I'll be taking, so I'm going to go home and just rest overnight, and we'll see how it does, right? Common phenomenon, and we can capture that easily in terms of supporting timeouts, so that people leave after a certain amount of time. So, for example, we can specify after how long they leave, right? Now, the key thing here, as far as I mentioned 2 key nexi, this is the other key nexus. So when they leave this service request, we notify them that they have been cured of their malady, okay? And how do we do that? Well, we refer here to entity. That entity, of course, is being suggested by this little thing here. So basically that's referring to the entity flowing through. Now in AnyLogic 7, agents and entities are one and the same thing. That distinction is erased. And so it's particularly straightforward. You could do this in AnyLogic 6, but it required a mechanism known as subclassing to do it. Basically each entity had to be created in a way that it would carry around almost in the pouch of a kangaroo the agent associated with it, and it could then notify it, send it messages. In this case, the entity is the agent, so we could simply send the entity a message, just like you recall in SIR models, in infectious disease models, we would send an infection message or an exposed message. Here we're sending the cured message, and for lack of a better, particularly more compelling way to do it, we're sending it to the entity from the entity. We're saying, hey, you're cured. Now, that reception of that message, in turn, provides that other key sort of link here, which is that's what allows them, when they're seeking care, they go back and when they receive this message, this is a message transition that brings them back from seeking care to not seeking care. When they receive a message, they simply make a report that they're cured and they go back to this state. So I want to be clear about this, and this is a very important point. While these agents are in this care process up there, they are in all ways live. They're always, they're still evolving, and therefore they're, in every way interacting with other agents, etc. That's very important to understand. So they're aging, they are undergoing processes, they may develop conditions. If you're considering presenting for care for an infectious disease, they may be progressing through successive stages of the natural history of that disease. And that's all going on while they're in that care process. It's not like they're frozen there. However, in this case, they are, the actual interaction occurs the other way by sending them a message by which they go back to this state. Does that make sense? Okay, so this is a model that brings together DES and ABM in a way that plays to the strength of AnyLogic 7. Okay. Very powerful notion, and I think the Krugerian model illustrates this fairly well. You imagine a care facility. Care facilities are often associated with resource-limited care, multiple pathways of care, and here we can capture these agents that can be arbitrarily rich quantities and can interact with that care all through the care process, through messaging or other requests or balking or what have you. Okay, so it's a very powerful metaphor, and one which this just illustrates in its barest bones. My goal here was to boil it down to the simplest thing so you can see very clearly how it works. Okay, so that's one form of hybrid modeling. I have other examples which show this in the context of a real-life clinic where there's clinicians, there's attendings, and there's clinicians in training, and a clinician, an attending is needed to sign off on an HPD, and you need to bring them in at some point, and there's waiting associated with that. And if anyone's interested, people present for the clinic because of pain, and they're treated, and then they're discharged, and it may or may not work as a discharge treatment. There's also other versions of this model which show probabilistic outcomes, and where they're shown in rather bold terms, which is maybe a bit too frank, but either they're successfully treated and they emerge, or there's adverse events that occur of the most lethal sort. These models boil it down to the bare minimums to communicate the essentials, and in this case, it's an absolutely minimalist model. So with an eye towards time, I'm glad to answer any questions with this, but I would suggest going on to another one. And if there's interest, I can present greater detail on any one of these models later. Kurt's model also would be particularly insightful as an elaboration of this basic scheme. Because Kurt, you did a fairly similar scheme in the sense that they presented for care, but you have a much more intricate care pathway and so on, and much more intricate, I think, significantly more intricate agent formulations. Okay, so let's go further to the next model. I'm going to show a very different form of hybrid model here, which comes in the form of a. So actually, I should probably, just with an eye towards nugget